Okay, let's say there's something that you want to buy and it has an original price. And you just don't like that original price. It's too high. So you wait for it to go on sale. That way you can pay a lower final price. Well, how do you figure out what the original price is if you only know the final price and how much it got marked down? Just as an example, let's say that your final price for a jacket was, I don't know, 80 bucks. And so you go to the store, you buy this jacket for 80 bucks, and it was marked down by 30%. You want to know if someone went in there the day after the sale ended or even the day before the sale started, what would they have paid without the markup or without the markdown, without the discount? That's what this video is about, how to figure out what that original price was. Usually I sell this to students as a buying something thing because they all understand, students all understand, oh yeah, I understand sale prices. I'm going to wait for it to get cheaper and then I'm going to buy it when it's cheaper. But the truth is, this doesn't apply to just buying stuff. It also applies to lots of science things. For example, like a cancer patient might have, a thousand cancerous cells, and when they take a certain medicine, it's going to reduce their cancerous cells by, I don't know, 40%. And then they're going to have some final number of cancerous cells that's hopefully going to be lower. So this is totally science stuff, but usually, like I said, usually I tell it to students. I make the example of buying stuff because that's something that they understand. So let me clean this up. I'll be right back. So here's what I'm going to do. Rather than write all these things over and over again, I'm just going to use a letter, or a math person would call it a variable. I'm going to say that the final price is A. I'm going to say that the original price is B, and that's in two places here. And I'm going to say that the percent markdown is C. So how much, what the sale was, 20% off or whatever. So I'm going to rewrite this. So it's going to be A equals B minus. I could write this CB, but the alphabet goes B then C, so I'm going to write it like this: B times C. I hope you don't mind, but it just sounds better to me when B is in front of C. So I guess what did I do in this step here? I just rewrote it. And I cleaned it up and I used variables instead of the words. So I've got a problem. And what's my problem? My problem is that B is in two places. And I'm like, how do I solve an equation for B if I want to know the original price? How do I solve it for B if it's in two places? Well, there's a little trick that I can use. And the trick that I'm going to use is this. If I divide this side by B, what's going to happen with these two B's? What's something divided by itself? B divided by B is just 1, right? So that way, I had B in two places. Now it's only in one place. It's right here. It's this B right here. Oh, shucks. I hate when I do that. 1 second. Okay, I got that cleaned up. So anyway, B divided by B, something divided by itself, is just 1. Everybody gets that. And then this B also cancels out this B right here. So because B divided by B is 1, so I've got 1 times C. So I've got my minus sign here. So I've just got this. So my whole right side now looks a little bit cleaner. I've got 1 minus C. Since I divided this side by B, there's a rule that says since you have an equal sign, whatever you do to one side, you've got to do to both. And most junior high kids know that. So if I divided this side by B, I've got to divide that side by B. So what am I at now? I'm going to just rewrite this. Whoops, I'm going to rewrite this right here. So I've got A over B equals 1 minus C. Now that doesn't look too bad. That doesn't look too complex. So what did I do? I divide both sides by B to get it in one place instead of two. Okay, so this is where I'm at now. I've got A over B equals 1 minus C. What's my goal here? My goal was to figure out what the original price was. I want B by itself. So if I want B by itself and it's divided here, I'm going to teach you another little trick. And it's a trick that you've probably already seen before, but that trick is called cross multiplication. If I've got a fraction on the left side, I've got a divided by b. If I want to get rid of that, or if I want to make the b not be on bottom, I'm going to take the right side, which isn't a fraction, and I'm going to put it over 1. Why in the heck would I do that? I would do that because now I can cross multiply. You might not see why I'm doing this right away, but you will in a second. Yeah, those highlights are kind of ugly, so let me get rid of them. Oh my, whoops. Okay, sorry, I keep messing up like that. The program's acting funny. But anyway, when you cross multiply, you've got the top of one side times the bottom of the other. So a times 1, that's just a. And then you've got b times the other side. So you've got b times 1 minus c. Okay, that might not seem to have helped to some of you guys, but it did. And let me slide this down a little bit, or slide it up a little bit. Okay, so what was my goal there? Why did I do this? What I did was I cross-multiplied. Ooh, I've been writing that in red, so let me do that again here. So my goal here was to cross-multiply to get my b off the bottom. If you're a math-savvy kid and you just said, why didn't you just multiply both sides by b? You're right, but I don't want to scare the non-math kids. So anyway, now I've got this. And what was my whole goal? My whole goal was to get the b by itself. Well, if b is by itself, how do I get rid of a multiplied 1 minus c? You divide by 1, divide by 1 minus c, and that cancels it out. But whatever you do to one side, you got to do to both. So finally, I'm done. b equals a over 1 minus c. That is my answer. b equals a over 1 minus c. So now I want to make up an example problem. I was talking about, what one did I talk about? Did I talk about like buying a coat? Was that my example? I can't remember. So let's say that the original price is our unknown. We don't know the original price. And let's say that we paid, let's say we paid 80 bucks for something. And let's say that the discount was 30%. All I'm going to do is I'm going to fill in these numbers, and this problem is going to be very easy to solve. So if you remember right, if you remember correctly, A is what we paid, and so that was 80 bucks. So I'm going to put 80 bucks right here. I'm going to leave off the dollar sign. And C was the discount, 30%. So that's where the C is. So 30%, you might remember, is 0.3. So this is all I got to do. This is pretty easy. What's 1 minus 0.3? That's 0.7, right? So I've just got to go 80 divided by 0.7. It's that simple. So let's see here. Calculator. 80 divide 0.7. So the original price of that $80 coat or jacket or whatever was 114 bucks and what, 29 cents, because this 5 rounds this 8 to a 9. So our original price was 114 bucks and 29 cents. So if you see a jacket for sale that's 114 bucks and 29 cents and it's too expensive, if you wait for a 30% discount, you will pay 80 bucks for that coat. Okay? That's how you do it.